So new unit, first day, warm-up problem, find the area under x squared from 0 to 2. Super easy, you've done that. That's just to remind us that the antiderivative tells us the area. New today is area between curves, and so it's sort of like way back in geometry when you found, you would sometimes find like goofy areas, like find the shaded area, and you'd have to do like the full square minus the missing piece. Does that sound familiar? With those complicated kind of shapes? Well, it's sort of the same thing here. So we'll do the area under F minus the area under G. And so how Bryce said it was area under F minus area under G. That's not wrong, but there's a simpler way to write that. And that is, we could just do F minus G. That's the same thing. So Bryce, what you said was right. You could do it that way every time. It's just when we get to using a calculator, it's going to be easier to put in one integral rather than two integrals. But those are exactly the same thing. If you want to sort of go through the derivation of it, it's each little slice has a height of F minus G and a width of what we call dx. So the area of that one little rectangle slice is F minus G times dx, base times height. And then that integral sign, it's an elongated S, which means sum. We're going to add up all of the F minus G times dx. We're going to add up all the little rectangles from A to B. Now, more generically, let's go from A to B, and we just say it's the top equation minus the bottom equation. So be careful, I wouldn't memorize F minus G, it's the top minus the bottom. So we have to be very careful about, and that's kind of a big deal on some of these problems. On some it's easy, but on some it's kind of tricky. It's like, well, how do I know which one is the top and which one is the bottom? Sometimes it's easy to tell, other times you have to graph and be real careful about which one's which, but make sure you're doing the top minus the bottom. I will say this, area is always positive. Do you know what would happen if you got those backwards? You'd get negative. So this isn't guaranteed to fix your mistake, but if you do all the work and you get a negative answer, especially if you're just like running short on time, then assume you got those backwards and make it positive and go on to the next problem. That's not a guarantee to fix it, but if you're pressed for time and you get a negative, it might mean that you just switch those. Let's be careful if we're doing dx. That means that means A and B have to be x values. We've kind of talked about that before when we did u substitution. If you make this u, then you have to make your limits u. Same thing. If we're doing a dx problem, then our limits have to be x things. Otherwise, it makes no sense. But sometimes people get confused to put y values there. But if we're adding up all the rectangles in the x direction, then the limits have to be x values. Okay, that's the one we like, because that's the one we're used to. Top minus bottom dx. If we want to get a little bit crazy, we can go with kind of a sideways looking problem. So we can draw a rectangle in there. The height of that rectangle is F minus G. You're gonna have to either turn your head or turn your paper maybe to visualize what's going on here. But the height of that is F minus G. And then here's maybe the tricky part. What's the thickness of that rectangle? Compare it to the thickness of this rectangle. So that thickness is dy. So let's add up all of those rectangles. But now we're not doing top minus bottom, we're doing right minus left. Right equation minus left equation times dy. And if we're going in dy, then our limits need to be y values. I'm going to call them c and d just to keep it separate from a and b. Again, if we're doing dy, then we've got to do y limits. If we're doing dy, our limits have to be y limits. If we're doing dx, our limits have to be x limits. C and D are y values. Most of our problems are going to be dx problems, but occasionally we like to throw in a dy problem. It really makes you slow down and think about, right minus left from bottom to top. Okay, again, the x stuff's pretty easy. You guys figured out right away. It's just top minus bottom. The y stuff is a little trickier, but we'll do some examples in a minute. All right, number 1. Find the area of the region. And by the way, some of these we're going to do no calculator, and some we're going to do with calculator. Most of the ones on the worksheet are actually with calculator. But as a review of some integration stuff, I'm going to do the first 2 without a calculator, just to get some more practice built in. Okay, find the area of the region bounded by the graph of y equals x squared plus 2, y equals negative x equals negative 1, and x equals 1. Okay, x equals negative 1 and x equals 1, that's easy to find, I hope. X equals negative 1, x equals positive 1. Got that. I'm going to argue figuring out which one's which on the others is pretty easy too. How do you know which one is which? I mean, I think I know, but how do you know? Which one is x squared plus 2 and which one is y equals negative x? Nobody wants to talk today. I'm assuming you know which one's which. So, Grenier, how do you know which one of those equations goes, or which one of those graphs goes with which one of those equations?
It says negative x, so the negative slope.
Okay, so that's a good answer. You know what a negative slope looks like. So that's got to be that one. Was anybody thinking anything else? Leo, what were you thinking?
X squared is a
Okay. The x squared is a parabola, so that's got to be the parabola. So sort of both of those things work. Obviously, they both work, or you only really need one to figure out which one's which. If you have a calculator, then it's easy to put them in one at a time and just kind of mentally take note of which one is which. But if you don't have a calculator, you need to be able to figure it out. But parabola, line. Okay, so I need the integral of... what I like to answer first is this going to be a dx question or a dy question? Am I going to be doing top minus bottom or right minus left? Let's do top minus bottom. And so sometimes I even see people write that down. Top minus bottom, which means how thick are my rectangles, or is this dx or dy? That's sort of the same question. How thick is that rectangle? Dx. So I know it's a dx problem, which means my limits need to be x things. So while we're thinking, let's go ahead and put those in. So from what to what? What are my x limits? How far left to right do I go? Negative 1 to 1. And we already identified that the top equation is x squared plus 2. And the bottom equation is negative x. So careful, we got a minus negative in there. So I want the antiderivative from negative 1 to 1, x squared plus 2 plus x dx. Now, if we had a calculator, we would go grab the calculator and just type that in and let the calculator do the work. But I want us to get a little practice on our antiderivatives. So x cubed over 3 plus 2x plus x squared over 2 from negative 1 to 1. Sensing a safe stop in our near future. All right, plug in the top minus plug in the bottom. So 1/3 plus 2 plus 1/2. There's plug in the top. Minus plug in the bottom. Let's be careful with the negatives. So negative 1/3 minus 2 plus 1/2. And now we've plugged things in. It's calculator ready. I would safe stop that rather than worry about distributing negative signs and figuring out who cancels and common denominators. Like, nah. Let that stuff go. Safe stop. You guys have thoroughly embraced the safe stop, like grading the test. Lots of safe stop, which is good. Like you should. That way you don't mess up something silly, something dumb. Like safe stop it when you can. Number 2. Find the area of the region bounded by 2 consecutive intersections of the sine and cosine curve. So again, we got to figure out which one's which. Okay, so you tell me, how do I know which one's sine and which one's cosine? Pre-cal experts. Alan?
Sine of 0 is 0.
Sine of 0 is 0, yep. Sine of 0 is 0, so that means the one going through 0, 0 is sine. Means the other one has to be cosine. But while we're thinking about it, hopefully you remember that the cosine of 0 is 1. So cosine starts at a maximum. Alright, so now we've identified who is who, which is important for the top minus bottom to get that right. Okay, bounded by 2 consecutive intersections. It doesn't say which 2, I guess because it probably doesn't matter in terms of the area. And if you look at the picture, I think you can make sense of that. So there's 2 consecutive intersections. There's 2 consecutive intersections. And just by like symmetry, it seems like those would have the same area. There's 2 consecutive intersections. So now we get to pick which one we want to use, but I feel like the positive stuff would be easier than trying to figure out the negative stuff. So I need to know, where do sine and cosine have the same value? Where is sine equal to cosine? Unit circle experts. What's that? Pi over 4. And, in fact, these are labeled, so you could probably figure it out that way. That's pi over 2. That's pi. So yeah, pi over 4 is the first one. What about this second one? In between pi and pi over 2? Or if you're thinking unit circle, that would be... So Rabia, where do they intersect between pi and 3 pi over 2? 3 pi over 4 would be right up there, I want an angle between bigger than pi, less than 3 pi over 2. So it is over 4, but what over 4 would land you in the third quadrant? 5 pi over 4. So antiderivative. All right, top minus bottom one more time. A lot of times once you get rolling, you don't do that. Is this dx or dy? Dx, which means my limits need to be x limits, but that's what we just found. Pi over 4 to 5 pi over 4. Top minus bottom. This is maybe tricky because it keeps changing who's the top function, who's the bottom function. But on the window that we're looking at, the top one is the pink one, the top one is sine. So sine of x minus cosine of x dx. And again, if we get a negative answer, that means we got it backwards. So there's a bit of a check on this. All right, well now let's integrate. So Tyler, what's the antiderivative of sine? Good. And Alan, the antiderivative of cosine? Sine. So I end up with negative cosine minus sine from pi over 4 to 5 pi over 4. And make sure you do the antiderivative before you plug in value. Surely we're past that, but occasionally, at least early on, people would get here and they would not integrate. They would just plug in top minus plug in bottom. Like, no, make sure you take care of the antiderivative. Then we'll plug in the top minus plug in the bottom. So negative cosine 5 pi over 4 minus sine of 5 pi over 4. All of that minus negative cosine pi over 4 minus sine of 5 pi over 4. And good news, I guess, we're out of room, but that's a safe stop. You can leave trig stuff as safe stops. Now, multiple choice test, obviously they're going to clean that up, but that is a safe stop, which is good because there's a ton of negatives in there. I guess the unit circle pieces aren't easy, or aren't hard. They're all root 2 over 2. Whoops, I wrote something down wrong here. Yeah, that should be pi over 4. All right, so top minus bottom, A to B. Let's do a couple more. This time we can start using a calculator so we can get some cleaner answers, and we'll start to understand if our answers make sense. Number 3. Let S be the region bounded by the graphs of 3x cubed minus x squared minus 10x. Again, we're using a calculator on this one. And g of x equals negative x squared plus 2x. It doesn't say from where to where, it just says bounded. But I see some limits on the picture. Okay, let's first figure out which one's which. So how do I know which one is F and which one is G? Even without a calculator. Like, we could use a calculator, but I don't need it for this yet. How do I know which one's F and which one's G? People to help us out here. Ian, how do you know which one's F and which one's G?
G of x would be the parabola one.
Perfect. G of x is a parabola. And we're not seeing the whole thing, but clearly the other one's not a parabola. So there's G, which means the other one is F. The other one's x cubed. I know generally what x cubed looks like. And that's what this one looks like. So there's F. My limits, this one's kind of nice because they give me the picture. negative 2 and 2. But there's kind of a trick to this one. Is it dx or dy? That's not the trick. Is it dx? My rectangles would be x rectangles. So dx. Which one's the top equation? F or G? And this is the tricky part. Right? Because, part of the time F is the top equation, and part of the time G is the top equation. Any thoughts on how we could handle that? Yeah, split it up. So I always have to do top minus bottom. So for this first part, I'll do F minus G. And then for the second part, I'll do G minus F. So I've always got to do top minus bottom. So when I'm doing F minus G, what are my limits from what to what? Negative 2 to 0. Or I guess another question is, when is F the top equation? Well, from negative 2 to 0. And G is the top equation from 0 to 2. And now we're just about ready to put this in. I'm going to put him in for y1 and y2. That way I don't have to type those things in multiple times. So I'm going to make y1 3x cubed. Again, grab a calculator, do this with me so you make sure you know where all those buttons are. So there's y1, y2, negative x squared plus 2x. I suppose if I really wanted to make sure I was looking at a good problem, I could go to the window and graph it. And I know where to graph it because I'm just trying to replicate this window. Goodness, I can't read those numbers. I'll just go negative 10 to 10. Close enough. So that picture should look like the picture we've got. Yep. Yeah. Okay. So that I just graphed it just to make sure I typed them in right. Now I can go. Do you remember where to find the antiderivative symbol? Math. It's either 8 or 9. I think it's 8 or 9. 8 is the derivative, 9 is the integral. So math 9. And then you just plug in the pieces. Negative 2 to 0. F minus G, that's y1 minus y2. So vars y1 minus vars y2 dx. Now I'm just thinking, do I want to find that and add it, or do I want to shove it all in at once? Probably safer to find it first. That way you kind of catch if you made a sign mistake or something. So I'm going to just hit enter and see what that is. 12. Okay, that's nice. That's a nice answer. So that means this area is 12. And then the other one, math 9, 0 to 2. And now I've got to do G minus F. So y2 minus y1. Vars y2 minus vars y1 dx. Also 12, which is kind of weird because those shapes don't look alike. Right? They're not identical shapes, but they do have identical areas. And so that total area is 24. Do you know what would have happened if you'd have just done F minus G from negative 2 to 2? Do you know what your answer would be? I feel like it would be something that you would catch. If you did F minus G the whole way, then this part would be negative, and 12 minus 12 would be 0. And hopefully you would realize, wait a minute, I can't tell by looking what that area is, but it's clearly not 0. Like the sum of those areas is something. So that one, you would have caught the mistake if you did f minus g the whole way. All right, again, the point of that one was be careful, it's always top minus bottom, so you may have to split it up to make sure you get top minus bottom the whole way. Number 4. Let R be the region in the first quadrant bounded above by the graph. Oh, this helps me figure out which one's which. Above by the graph of x equals 4 cosine pi y over 4. Like what? I don't know, but that's that one. And below, why am I thinking that's not right though? Below by the graph of 2 minus y squared, so that's that one. Okay. So area, is this going to be a top minus bottom or a right minus left? Maybe it's hard to tell by looking, but you look at those equations, and those equations are x equals equation. That feels backwards. Speaking of backwards, this is going to be a dy problem. We're going to add up the slices. We're going to add up the dy slices rather than the dx slices. So I need to do right minus left, and my limits need to be y limits, so not 0 to 4 but 0 to 2, because again, if I'm adding up dy, I've got to have y limits, and my equations need to be y equations, but that's part of how I knew this was a dy problem, is I've got y equations. Okay, the right equation, at least according to this, I thought it was the other way, but we'll find out. If we get a negative number, it means we were backwards. The right equation is this one because it told us this was the right equation. 4 cosine pi y over 4 minus the left equation, 2 minus y squared. And so that looks terrible, but this is a calculator problem, so I can just type it all into my calculator. Now, let's type it in. So math 9, 0 to 2, 4 cosine, I'm going to do the fraction bar here, get really fancy, pi times y. So the y button is down on the bottom left, like second y, pi y over 4, close parentheses, minus parentheses 2 minus y squared dy. I think I got all that in there the right way with all the parentheses in the right spot to square the right thing and to cosine the right thing. .302. So yeah, how do I know that's right? I don't. Other than it's positive, so at least that means I got the right minus left thing correct. It's kind of a yucky one. The y's are kind of yuck. Uh-oh, what did I do wrong? What's that? I did over 7 instead of over 4. Thank you. Let's change that. I'll obviously change my answer. Good catch. There we go. Is that better? Is that what you got? When you put in the right answer or the right formula? 2.427. that would be a great example of why you show your work. Grading the test yesterday, when things like that happen, I usually write something like, yes, that's correct. And then where did that come from? So I'll write no, question mark, like, I don't know what happened, like, other than you probably made a calculator mistake. So you get 3/4 of the points or 4/5 of the points or whatever if everything's nice and neat and everything's correct except you type something in the calculator wrong.
Is asking for the volume, does that change anything, or is it still just...
The volume of the region? It should not be asking for the volume of the region. We're not doing volumes yet. You're right, because volume would be a 3D thing. We're not ready to do that yet. We'll do that tomorrow or Friday.
Sorry about what's the Y button?
Okay, Y button. Oh, I'm glad you asked that, because I'm going to answer your question and then I'm going to give you a cheat code. So the Y button is down here, bottom left. So alpha Y. Okay, cheat code. Any ideas on how I could like trick the calculator into doing this problem, but I can use fewer buttons? I can use X. The calculator doesn't know that we're X versus Y. Like the calculator just does whatever you tell it to do. So Math 9, I can use X things. I can use the X button. So pi, it's just easier to do. Pi x over 4, not 7, minus 2 minus x squared dx. I hesitate to show this because this is not a dx problem, but it's just a whole lot easier to use x's in the calculator. Your calculator doesn't know it's an x problem. You just switched variables and that should give me the same thing. I've still got 2.426. So if that bugs you, then yeah, take the extra 5 seconds to use y's and be fine. If it bugs you to keep hitting the y button and you'd rather use x's, that's okay too. Like, I'll never know which one you use because that was a calculator thing. And obviously your calculator doesn't know the problem, it just does what you tell it to do. Number 6. This is a favorite question to ask on AP tests. Let R be the region bounded by the graph of y equals e to the x plus x. Okay, that's weird, but there's only one equation on this thing, so that's got to be e to the x plus x. And the x-axis, all right, on the interval from 0 to 2. Okay, I'm expecting it to ask me to find that area, but instead it says there's a vertical line x equals b, vertical line that divides this region into two regions of equal area. Okay, we'll just eyeballing it here. Where's that line going to be? Is it going to be at 1, left of 1, or right of 1? The right of 1, because I want the areas to be the same. So trying to eyeball it, who knows? Maybe it's there. And I want those two areas to be equal, because that line, that's what it said to do. Like, there is a line, I don't know where it is, that divides R into two regions of equal area. So A1 now equals A2. And B is my dividing line. This is nice. Shows up not on every AP test, but pretty frequently. Write but do not evaluate. That's good news, right? Like, that means I don't have to worry about calculator or no calculator or doing this by hand or punching buttons. Like, just set it up. An equation containing an integral or integrals, which when solved would give the value of b. So like, write something that has b in it that if we wanted to solve we could. Well, a1 equals a2, that's sort of the key to this problem. How can I find a1? Let's write an expression to find a1. So that would be antiderivative, it's dx. From what to what? What are the limits for a1? 0 to b of e to the x plus x. So that's a1. a2, the other side. What are my limits for a2? b to 2, also of e to the x plus x. And so I think that's it. I've got an equation containing integrals, plural, which when solved, meaning I don't have to mess with it, but if I solved it, so if I took an antiderivative and plugged in b and 0 and 2 and b and did all sorts of algebra, I could figure out what b is. So write but do not evaluate, we like that because it's all about the setup. You don't have to worry about solving it. There is a different way to write this or to solve this one with only one integral, which is why it's phrased that way. But I don't know. I've always thought this was the easier way. It said they're equal areas, set it up as equal area, be done. Okay, look at number 1. Worksheet 1, number 1. First period. Let R be the region bounded by, let's read the instructions because we like the instructions today. Use a calculator except when indicated. So usually it's the other way around. Usually it's like, don't use a calculator unless we say. Here it's vice versa. Use a calculator unless we say not to. Let R be the region bounded by those two graphs. Find the area of R. Okay, here's why I wanted to do this one with you. This is different because I don't have a picture of this. So how do I get a picture of this? Graph it. You got a calculator, so let's put those in. In fact, I'm going to go ahead and label them y1 and y2 because I'm probably going to do an integral at some point. One's a parabola, one's a line, so I should be able to tell pretty easily which one's which. But if you're worried about telling which one is which, then you can graph them one at a time. Like graph the first one, and you're like, okay, there's a parabola, sure enough. I wonder if that's enough to. I might need to see more than that, but let's graph the other one. 3x minus 4. Okay, so I'm going to back up here. Top minus bottom. It's going to be a dx problem. So I need to know which one's top and which one's bottom, and I need to know the limits. Well, I can tell the top and the bottom already because that parabola is the one on top. So that's y1 minus y2. How am I going to find the limits? From where to where? What would I be looking for? Intersections. So there's one of them down there that looks like it's at -2, but maybe I should go -3. The other side I didn't see it yet, so I'm going to go out to 5 and see if that helps. Okay, there we go. I think that's at -2, but thinking that's at -2 is probably not good enough. Let's go second calc intersect. Those intersections will tell me where my limits are. So first curve, second curve. Again, I'm pretty sure it's 2 at this one down here. Yep, x equals 2, y equals -10. I don't think I need the y value, but the x value is -2. The other x value, you have a guess at what it is? Looks like it's 3. And given this problem seems fairly straightforward, I'm guessing it's 3. But we can give you some weird ones where you don't get nice answers. So let's go make sure it's 3. Sure enough, it's 3. So they intersect at -2 and 3. So I want the antiderivative from -2 to 3 of top minus bottom dx. There's not a way to do this like on the picture. You can find the area underneath one of them on the picture, but you can't find the difference between them on the picture. So you got to back out to do math 9, -2 to 3. But I don't need to type them in again. I've already have them as y1 and y2. y1 minus 2 dx. And it's multiple choice, so hopefully when I press enter, one of those answer choices shows up. And it does. That's good. 20.833. So calculator was super helpful on that one because I needed to find the intersections. Calculator also helped me see which one was top and bottom. Oh, one more thing when it comes to graphing. I don't know if you know this or not, but if you scroll over to the left and press enter, you can change like the shading of that graph. You guys that have, a few of you have the new calculator where it puts them in different colors, yes? And so this is, I don't have different colors, but I can make them different weights. And so sometimes it's easy to know which one's which, other times not as much. And so if you make them different weights, then it's pretty clear that the lightweight one is the first one, the parabola, and the darker one is the second one. Again, that wasn't really necessary for this one, but sometimes if you get some crazy functions and you can't tell who's who, it might help to make them different colors, so to speak. I think you can also shade, but you can also dash, I think. Yeah, there we go. Make one of them dotted. Again, I don't know that we'll ever be, oh, that didn't dot it. Never mind. It also doesn't look very good. So yeah, just stick with the light and the dark. If you need to tell them apart. All right, why don't you try number 2? Same type problem. You got 2 equations. You got to figure out which one's the top and bottom. You got to figure out what your limits are. Put this on video here. So there's the setup. You had to find the intersections. Top minus bottom. Some of you saw this. When you get an answer on the calculator, it's like 1.5 and then a whole bunch of zeros. And then 237 is what mine was. Yours might even be a little different than that. When your calculator does antiderivatives, do you remember how we approximated antiderivatives? What method did we use to approximate area? Think back. What method did we use to approximate area? We used Riemann sums. We added up the rectangles. When your calculator is calculating areas, it's using Riemann sums. Now, it's not doing like 3 or 4 rectangles like we did. It's using like 1,000 rectangles. But it's still an approximation, which is why once you get out here to whatever, the 6th, 7th, 8th decimal place, it's like, well, maybe it should have done a million rectangles instead of 1,000 rectangles. But that would have taken the calculator longer to do. And so sometimes you get answers that's like, wait a minute, is that right? And the reason it's not right is the calculator used an approximation. I mean, again, it used way more rectangles than we would use, so its answer is right to the nearest 1, 2, 3, 4, 5, 6 decimal places. So that's good enough. But that explains why if you're looking for, a few of you check that, you're like, well, those aren't the same. You're like, well, no, they're not mathematically identical, but they're pretty darn close. So that may explain why sometimes the calculator spits out an answer that looks a little bit weird. But again, the calculator doesn't know calculus. The calculus knows how to add up areas. All right, try number 3. of the symmetry of the thing. So top minus bottom from -1 to 1. So again, you got to figure out where they intersect. You got to figure out who's top and bottom, and then put it in the calculator correctly.